Have you ever wondered how you tell a story that's 4.6 billion years old? Well, today we're going to give it a shot. We are rewinding the clock all the way back, to the very beginning, to find out exactly how our home, planet Earth, came to be.
So how in the world did a boiling ball of lava become, well, our home? It's kind of hard to wrap your head around, right? The idea that this planet, everything we see, everything we know, was once just a world of fire, a total inferno. So how did it make that incredible transformation into the blue and green world we live on today? That's the amazing story we're diving into.
Okay, so to start, we have to go back, way back. 4.6 billion years ago. Forget Earth. It wasn't even a thought yet. Out in the quiet, empty darkness of space, there was really just this giant, drifting cloud of gas and dust. Astronomers have a name for it, the solar nebula.
And for ages, that's all it did. It just drifted, peacefully. But then, bam, something absolutely incredible happened. A nearby star, a really massive one, died in a spectacular explosion, a supernova. The shockwaves from that thing were just immense. They ripped through space and slammed right into our quiet little nebula. That collision was the trigger. It squeezed the cloud, causing it to start collapsing in on itself. This was the cosmic spark that kicked off, well, everything.
So, as this cloud started collapsing, it also started spinning, flattening out into this huge disk, kind of like pizza dough, and gravity, it just started doing its thing. It pulled almost all of the gas and dust right into the center. As all that stuff got crammed together, the pressure and the heat just skyrocketed. We're talking unimaginable levels. Eventually, the core hit a staggering 15 million degrees Celsius, and at that exact moment, ignition. A massive nuclear reaction started, and our sun just switched on. A star was born.
Just think about that. Our sun is an absolute beast. It gobbled up 99.8% of all the material in that original cloud. It's the whole show. So, what happened to the leftovers? That tiny little fraction, just 0.2%? Well, that seemingly insignificant cosmic dust, that's where our story really gets interesting.
Yep, welcome to the Planet Factory. Let's look at how that leftover dust and debris built not just one, but all the planets in our solar system.
The key to all of this is a process called accretion. It's actually a pretty simple idea. It's just gravity's way of building things. Little bits of stuff get pulled together to make slightly bigger bits of stuff, and those bigger bits pull in more stuff, and so on. It's how you go from tiny dust grains to giant planets. It really is like a cosmic assembly line. At first, it's just tiny dust particles, kind of like static electricity, sticking together. But give it millions of years, and these little clumps grow into things we call planetesimals. We're talking kilometer-sized rocks. Once they get that big, their own gravity starts to become a big deal, and they start pulling each other in, forming these massive, moon-sized objects called protoplanets. It's a slow process for sure, but it is steady.
All right, so let's zoom in on our own backyard. The birth of Earth, well, it wasn't pretty. It wasn't gentle. It was an absolutely brutal, chaotic trial by fire. This period has a very fitting name, the Hadean Eon.
And yeah, that name tells you everything you need to know. It's named after Hades, the Greek god of the underworld, for a reason. For millions of years, the young Earth was a literal hell. It was just a ball of molten rock, constantly getting smashed by asteroids and comets. This never-ending bombardment kept the entire surface a bubbling, roiling ocean of lava.
But in all of that chaos, out of all those millions of impacts, there was one collision that was different. One impact so huge, so world-altering, that it completely changed Earth's future. Scientists call this the giant impact hypothesis. And the story goes like this. A rogue protoplanet, they named it Theia, about the size of Mars, came hurtling through space and smashed right into Earth. The impact was, well, cataclysmic is an understatement. The dense iron cores of both planets actually fused together, while a massive cloud of lighter, rocky material got blasted out into orbit. And that cloud of debris, over time, gravity pulled it all together, and it became our moon. So you might be thinking, that's a wild story, but how do we know what happened? Well, the evidence is pretty clever, and it's all about the core. See, Earth's big, dense iron core makes up about 30% of its total mass. The moon's core, though, it's tiny, super tiny, less than 2% of its mass. That's the smoking gun. It tells us the moon couldn't have been some random planet that got captured by our gravity. It had to have been formed from the lighter, rocky outer layers of Earth and Theia that got ejected during that collision.
But wait, there's more. That impact did something else, something incredibly important. It literally knocked our planet sideways, giving us the 23.5-degree tilt on our axis. Why does that number matter? It's the reason you experience summer, fall, winter, and spring. Without that tilt from that ancient collision, we wouldn't have seasons. Our climate would be totally different, probably way too extreme for life like us to ever have a chance.
So, with our new moon in orbit and the worst of the chaos over, Earth could finally begin its next great transformation, from a world of fire to a cradle for life. It's a process called differentiation. You can think of it like a bottle of salad dressing. As the still molten Earth started to cool, all the heavy stuff, we're talking iron and nickel, sank right down to the center. That formed the core. All the lighter stuff, the rocky silicate materials, floated up to the top. That eventually cooled and hardened into the crust that we live on. It's how the planet basically sorted itself out into layers.
And that core isn't just sitting there. It is crucial for us. The outer part of the core is liquid, just churning molten iron, and it acts like a giant engine or a dynamo. This generates an incredibly powerful magnetic field that surrounds our entire planet. It's like an invisible force field, our own personal shield that protects us from all the dangerous radiation blasting out from the sun. No shield, no atmosphere. And no atmosphere means no life. It's that simple.
Okay, we've got layers, we've got a shield, but what about water? You can't have life without water. So where did it all come from? Well, it turns out it was basically delivered from two sources. First, from space. Icy comets and asteroids that were still hitting us brought a ton of water. And second, from inside the Earth itself. Huge volcanoes were constantly erupting, releasing massive amounts of water vapor that had been trapped inside. As the planet finally started to cool down enough, all that vapor in the atmosphere condensed, and it started to rain. And rain. And rain. For millions of years. That's how our oceans were born.
So when you step back and look at the whole picture, it's pretty mind-blowing. Earth ended up with this perfect, just right recipe for life. We're in the Goldilocks zone, not too hot, not too cold, so water can be liquid. We're just the right size, with enough gravity to hang on to our atmosphere. We have that amazing magnetic shield to keep us safe, and all that volcanic activity eventually gave us a stable, warm climate. It's just this incredible chain of events, one lucky break after another.
So there you have it, from a simple cloud of dust to a raging ball of fire, and finally, to home. That is the 4.6 billion year story of our planet, a story that was written in cosmic violence and shaped by unbelievable luck. And it really just leaves you with one big question to chew on, doesn't it? If our world was born from so much chaos and so much pure chance, just how rare is a place like this?